In this segment, we're going to talk about cross-lingual pre-training, and we're going to start with ideas of things like word embeddings that can unify representations across different languages. And we'll see in a little bit what some of the benefits of this are. So the idea is that suppose we have corpora in a bunch of different languages. We could use something like the skipgram method to train word vectors on each of these languages in isolation, right? But then the word vector in one language will be kind of totally unrelated to any of the word vectors in other languages. Instead, it would be nice if we had a shared embedding space where all the words in these different languages sort of coexisted. Now again, there's a lot of sort of divergence between languages that makes this not necessarily that clean. But if we have apple in one language and apple in another language, ideally we would want those things to be similar, and that might enable us to do certain things with this model that we otherwise couldn't do. Okay, so what happens? So if we have sentences like I have an apple or j'ai des oranges in French, we can form clusters based on dictionary translations of words. So for example, a and have are translations of one another, and I in English and je in French are also translations. And so we can just get this out of a dictionary and map these things down to basically cluster IDs. Then we just label all the words in these sentences with their cluster IDs, and then we treat these as the words in word2vec. So these dictionaries let us label things with these clusters, and then we train what we think of as monolingual embeddings, or just the standard skipgram model, over these corpora. So then you're going to have one embedding for the things in cluster 47, and you're going to have a shared representation for I, je, and that's great. That was kind of our goal. Okay, so this kind of thing works okay, but not all that well. Like the vectors are definitely, there's some problems with assuming these kinds of correspondences, and it's sort of not as effective as standard word embedding techniques monolingually. Okay, so the question is, how do we bring to bear maybe some more sophisticated ideas on this problem, and what can we do? So one idea from Artech et al. Is to think about going beyond the level of words and actually produce sentence embeddings. So what they do is they have a shared BPE vocabulary between a whole bunch of different languages, and then they train MT systems on a bunch of bitexts between these languages. And the kind of key thing here is they do not use attention. They instead boil down the source sentence into a single sentence embedding and then feed that into the decoder. And the reason is because they don't actually care about this as an MT system, they care about getting at that embedding. And the idea here is that by having different bitexts use shared encoders and different decoders, you sort of have, if you have English translating into two different languages, it's going to produce one shared representation, and then the decoders in other languages are going to operate from these shared representations. So the encoder here should really be mapping each sentence into some sort of relatively universal vector W that can then come from any language and also be translated into any language. So again, from the perspective of MT, this assumption is too strong and is not necessarily going to work well. But from the perspective of building a very effective sentence encoder that's going to produce vectors W, it actually works pretty well. And so what they do is they look at the task of natural language inference. So remember that this was like looking at two sentences and deciding whether they entail each other or contradict each other or are neutral. And so they can train a system on English and then evaluate it on other languages. They train it with these basically to operate over these representations W of the two sentences in this case. And then they can swap in French sentences into their encoder, right? And their French encoder, or their encoder, which is shared across all languages, should encode those French sentences into the same representation space as we had for the English sentences. So then our NLI model, which is trained on English, should then work for these as well. Okay, so the results here are kind of pretty good. They managed to get some decent results out of their BILSTM encoder, and it works a little bit better than previous cross-lingual techniques. Okay, so we could extend this further. We went from kind of word encoder to sentence encoder, and now we can go to more complex pre-trained models, which kind of operate as both, right? You get the benefits of encoding different words from the last layer of the BERT model, and you also get this kind of flexible CLS vector that can do sentence classification tasks. Okay, so there's this model called Multilingual Burger. Well, there's several models now, but one of the original ones basically took a bunch of different Wikipedias and trained BERT on all of them. Now, what you might be thinking is, all right, so isn't that just going to basically get you, maybe you have some shared parameters, but you're basically going to get a kind of, BERT that knows about Chinese words and a BERT that knows about English words, and like these won't necessarily have any sort of translational equivalence, let's say. And that's definitely a valid concern, and we don't really know, or I haven't seen a study of how strongly that's true. But what is true is if you look at Wikipedia, you will see kind of instances of code mixed text where you have text in one language or one script intermixed with text from other languages or other scripts. And so even though there's not a strong notion that Wikipedia is a bitext or anything like that, we still might see enough co-occurrences of things that we might expect the representations of this stuff to at least have a little bit of shared structure. Now remember, with masked language modeling, it's the case that you might mask out some of these Chinese characters in this article at the bottom from Russian Wikipedia, and then you still need to be able to predict them from the context, right? And so the model is going to be encouraged to cast all these things into the same embedding space as much as it can. All right, and so this kind of holds up if we think about tasks like named entity recognition and part of speech tagging. Again, we can train a POS tagger, what we see in the top right here. We could train a POS tagger on Italian or fine tune, this BERT model, and then run it on English, and we get 86.79% accuracy on this POS tagging problem. And so this is, again, a kind of direct transfer approach where we can take a model and directly run it on a new language without any fine tuning, and it works okay. Now there's some interesting patterns here where languages that are maybe more related exhibit kind of higher performance when we do this. By the way, the diagonals here are just the results when you fine tune and then eval on the same language. So that's like the sort of standard BERT setup that we've been using prior to this segment. I will note that like all these languages share an alphabet, and so you could get a lot of benefits in transfer between Spanish and English just by being able to leverage, not just shared words, but shared parts of words, and the fact that at least they're grounding out in common like subword tokens at the bottom. But the cool thing is that this actually works well transferring between different scripts as well, such as Urdu to Hindi, which are written in two different scripts. And same for Japanese to English. So we can similarly, there's obviously some, performance cost to this, but we could train a tagger for English and transfer it to Japanese or vice versa. And that's a very cool capability for these models to have. So there's a lot of work in building kind of cross-lingual or multilingual pre-trained models, and this allows us to build systems that then transfer very effectively between these settings without needing a lot of data. So all of this we've kind of seen is building towards ideas of having systems that are more flexible, that don't necessarily need large tree banks or part-of-speech corpora or whatever in order to work for other languages. And this is going to allow us to build NLP tools that can work for much larger fractions of languages in the world without having to go through and annotate a whole bunch of data for each of them. So it's a very exciting time for this area in particular. There's a lot of progress here being made very rapidly over the last couple of years, and so it'll be very exciting to see what kind of new systems this yields as a result. That's the end of this segment.